minus 2 is 7 halves times x minus 1. We are going to distribute. So this becomes 7 halves x minus 7 halves. Negative 2 moves, becomes positive 2 or 4 halves. And therefore y is negative 7 halves x minus 3 halves. So what is the equation of a tangent line? You have a pair, you differentiate, you plug in, you get the slope. Y minus y1 is m times x minus x of 1, and you must simplify, put it in slope intercept format as the final answer. Find dy dt for the equation x e to the power of y plus 4x equals y cubed. Dx dt is 2, x equals negative 1, y equals 0. The moment you see dy dt, you should recognize the independent variable is t, which means the derivative of x is no longer 1, but rather dx dt. So let's differentiate, and we recognize this one as x times e to the power of y. We put a raised dot, and we are going to go with the product rule. So f prime g plus g prime f. This is the one we are going to use. The derivative of x is dx dt times g e to the power of y. And the derivative of the g e to the power of y is e to the power of any exponential is itself, e to the power of y. And then y, its derivative is dy dt times f, which is x. So what we are looking at here is f prime g plus g prime f, and 4x for dx plus 4 dx dt, y cubed. The derivative of y to the power of n is ny to the power of n minus 1 y prime, or n to ny to the power of n minus 1 dy dx. In this case would be dy dt. So 3y squared dy dx changes to dy dt because t is the independent variable. And we're done. We can solve for dy dt, or we can plug in. So I'm going to just plug in. So dx dt is replaced with 2 e to the power of 0 plus e to the power of 0. Dy dt is missing. X is negative 1. 4 times dx dt is 2. 3 times y is 0. 0 is squared times dy dt. So just plug in, and obviously this is 1, 8. This is 0. This entire thing is 0. So what do we have left? On the left side, we have 2. Plus 1 times negative 1 is minus dy dt plus 8. And on the right side, we have 0. 2 and 8, they add up to 10. Move this, and 10 becomes dy dt, or dy dt becomes 10. Differentiate y equals 2x times ln of 3x squared. Although we can simplify and decompose a natural log, but because this requires a product rule to start with, it's not going to make it any simpler. So let's Put the raised dot to show that we are going to use the product rule. F prime g plus g prime f. F prime is 2. G is ln of 3x squared. Now, g prime, the derivative of a natural log, the derivative of g of x, flip it over, 1 over g of x, 1 over 3x squared, times g prime times the derivative of 3x squared, which is 6x. And then g prime f, then you multiply it by 2x. So what do we have here? 2 ln of 3x squared. What do we have here? 12x squared over 3x squared, which is 4. So the final answer, y prime is 2 ln of 3x squared plus 4. So there are times that we should decompose the log, not this time. For example, right here, we should decompose the log. If we don't, we say the derivative is the reciprocal of this, and then multiply by its derivative, which uses the quotient rule. However, I'm going to start with number 6. Again, you can do it in one shot. I'm going to do it in 2 shots. So the quotient rule says this is ln of 5x minus ln of x squared plus 5. And then I'm going to use the product rule and say log xy is log x plus log y. They have the same base. So ln of 5x is ln of 5 plus ln of x. It's completely decomposed, and I'm going to differentiate it now. ln 5 is a number. The derivative is 0. Ln x is 1 over x. Minus, I'm going to differentiate this. The derivative of ln of g of x is 1 over g of x. So 1 minus 1 over x squared plus 5. Then times g prime, the derivative of the inside is 2x. We're done with calculus. We notice we have 2 fractions. We take a common denominator, which is x times x squared plus 5. This one, 1 times x squared plus 5. And this one minus 2x times x. So we are combining the 2 fractions using LCD, and we are going to simplify the numerator as follows: x squared plus 5 minus 2x squared. These two combining to minus x squared. So the final answer is minus x squared plus 5 over x times x squared plus 5. G of x equals log of 9 minus x cubed to the power of 4. We should always decompose the log first. It makes it easier. So using number 7, the power rule, we put the 4 in front. That's the first step. And now we are going to differentiate this. So we start with number 4. Log 1 over g of x, 1 over the argument 9 minus x cubed, times g prime by the chain rule times the derivative of this piece, which is, so again, I'm using this. So I would write the formula and follow that. We're going to flip this over first. Then its derivative is negative 3x squared. Then the base is e, no. The missing base means 10, 1 over ln b. That means 1 over ln 10. So these two are in the denominator. 4 times 1 times negative 3x squared times 1, that gives us negative 12x squared in the numerator. So the final answer, g prime of x, is negative 12x squared over 9 minus x cubed times ln 10. Y is x squared over x minus 8. We want to find dy. So to find dy, we're going to ignore that. We're going to differentiate this. In other words, we're going to find dy dx, meaning we're going to use the quotient rule. F prime g minus g prime f over g squared. So f prime is 2x times g, which is x minus 8, minus g prime, the derivative of the bottom is just 1, times f, which is x squared, then write the bottom and squared. So this is dy dx, or the derivative of the given function. We need to simplify. Two x squared minus 16x squared minus x squared. These two combine into x squared. So the numerator is x squared minus 16x. The bottom doesn't change. This is dy dx. dy is exactly the same thing times dx. Now we want to evaluate dy and delta y when x is 4 and dx or delta x is equals 0.2. So it simply means replace the x here and here and here with 4 and dx with 0.2. That's for dy. So 4 squared is 16, minus 16 times 4 is minus 64. 4 minus 8, negative 4 squared is 16. 16 minus 64 is negative 48, divided by 16. You get negative 3, times 0.2, you get negative 0.6. Delta y by definition is f of x plus delta x minus f of x. Therefore, it makes it f of 4.2 minus f of 4. We put here 4.2, we get 4.2 squared over 4.2 minus 8. Then we put 4 squared over 4 minus 8. And I hope you realize this was easy to calculate, but this is just that we may have to use a calculator. That's why sometimes dy is used instead of delta y as an approximation. Put it into a calculator. You see a number close by. And again, this was easier to evaluate. This, perhaps you have to use a calculator, and the two numbers are fairly close, negative 0.6 versus negative 0.6421. Use differentials to approximate cube root of 63.5. Number one, you need a function. And all you have to do, look at your operation, read the question. We want cube root of a number. So we want cube root of x. Step number two, choose an x to be a number close to 63.5 for which the cube root is easy to compute. We should know x is 64 because we should know cube root of 64 is 4, and that is the closest number to 63.5, which gives us dx or delta x the difference of the two, which is negative 0.5. So dx or delta x is 63.5 minus 64, which is negative 0.5. The meaning is important. We may not know what's cube root of 63.5, but because dx is negative, it has to be smaller than cube root of 64, which is 4. So now we have that, and we have f of x. So f of x plus delta x is f of x plus dy. But we do not have dy. To do so, we have to first differentiate this, which means we are going to rewrite it as x to the power 1/3, so the power rule can be used. Therefore, the answer is f prime of x is 1/3, x to the power of 1/3 minus 1, which is negative 2/3. We take this down, becomes x to the power of positive 2/3, or 1/3 cube root of x to the power of 2. You can put these two inside or outside, makes no difference. So this is f prime. So what is dy? F prime of x dx times dx. You can put it right here, or 1 times dx, put it at top. And so now we have both of them. So what is cube root of 63.5? It's f of 63.5, which indicates the choice for x is 64, for dx is negative 0.5. So replace the x with 64 here and here, dx with negative 0.5, any value. So obviously, cube root of 64 is 4. So this is 4. Square it 16 times 3 makes it 48. Now, the reason I'm changing this to a fractional format, class, the bottom is 48, the top is plus times minus 0.5 is negative 1/2. Now I have a complex fraction, and it's 1/2 times 48. So 4 minus 1/96. 2 times 48 is 96. Which is precisely in a fractional format, 3/95/96. And this is when you put it into a calculator, because I put this into a calculator, and I'll show you how close they are. That's the idea, everybody. The first 4 are identical, the first 4 decimals. Okay, and even if you stop here, you have to change it to 6, because this is 5, the same thing here. That's how close they are. Extremely close. We may use linearization, that means tangent line. So if you want to use linearization and find L of x, the question is, what is the function? Cube root of x. At what point? X equals 64. So what is the pair? When x is 64, cube root of that is 4. So 64 comma 4. What is the slope? Put the 64 into f prime of x. This one, as you put in 64, you get 4. Square root is 16, times 3 is 48, 1/48. So that's how you get this slope. I'm going to use the point slope. Y minus y1, that means y minus 4, equals m, that means 1/48. X minus x of 1 means x minus 64. So you distribute, you get 1/48 times x minus 64/48, and then you move the negative 4, and it simplifies to y equals L of x equals 1/48x plus 8/3. It is extremely important that you simplify and put it in slope intercept form, everybody. Now, if you plug in 63.5, instead of x and change it to a fraction. By the way, 63.5, you can say 127 halves, put it here, and work it out, simplified, you will get this number exactly. And the idea is that to show you the result of linearization and differential must be identical. And they are, otherwise we've made a mistake. Find the absolute max and mean values of the function f in the given interval, where f of x is x squared minus 1 quantity cube, and the interval is -1 to 2 is a closed interval. So I want to remind you that, number one, all functions are continuous in their entire domain, meaning if you recognize the function and if you can come up with the domain, that domain is where the function is continuous, and every function in its domain, and that's the key. So polynomials are in the form of f of x equals a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 all the way to a sub 0, where a sub n, the leading coefficient, can't be 0, and n is a whole number, meaning 0, 1, 2 to infinity. They all have a domain which is all real numbers. So what are we dealing with here? We are dealing with the polynomial of degree 2 times 3. The product of these two is the degree. So f is a polynomial of degree 6. It's continuous from negative to positive infinity, which makes it continuous in the given interval of -1 to 2. And so we can move on. And to move on with the extreme value theorem or the closed interval theorem, the methodology is number one, find CPs, which means you have to find f prime of x. So to find f prime of x, three times x squared minus 1 squared times the derivative of the inside 2x, which simplifies to 6x times x squared minus 1 squared. So that's f prime of x. But to find CPs, you have to set it equal to 0 or does not exist. So if I set this equal to 0, either x is 0 or x squared equals 1. So either this one is 0 or x squared equals 1. X squared equals 1 gives you plus minus 1. So there are three answers. F prime doesn't exist. Phi, it's an empty set, doesn't produce any solution because f prime is a polynomial of degree 2 times 2, 4 plus 1 is 5. Okay, so there are three answers, and we're going to check if all of them work. -1 is in between. Well, it's one of the endpoints. Work. 1 is in between. Yes, 0 is in between. So we can use all of them. And so we're going to evaluate the function at the endpoints A and B, as well as the critical points 0 and 1. So we're going to use the original function, f of x equals x squared minus 1 cubed. We're going to put -1 in it. And I hope you realize -1 squared is positive 1 minus 1 makes it 0, and 0 to the third power is 0. If I put 0, this goes away, -1 cubed, which is -1 is the answer. If I put 1, 1 squared, 1 minus 1 is 0, so to the third power is 0. If I put 2, I get 4. 2 squared is 4. 4 minus 1, so put 2, 4. Minus 1 is 3. So let's actually, so 4. Minus 1 is 3. 3 cubed, 27. So, and the last part, absolute max is the largest value, which is 27. So absolute max is 27 at this pair. Absolute minimum is the smallest value, which is -1 at this pair, and we write absolute maximum is 27 at 2 comma 27, and absolute minimum is -1 at 0 negative. All right, let's go to related rates. A small rock is dropped into a lake, circular ripples spread over the surface with the radius of each circle increasing at the rate of 3/2 feet per second. Find the rate at which the area of a circle is changing when the radius is 4 feet. Bear in mind, it's an application problem. You need to read it a couple of times, and then you have to define your variables. First and foremost, we are dealing with a circle. We should recognize the circle in this shape. From the center to the circle is called the radius, 2 times that. As you go from the center to both sides is the diameter. D is 2r. Circumference is 2 pi r going around it, and the area is pi r squared. So that's the first thing, piece of information from geometry we should have. So A equals pi r squared. Then we reread again. Circular ripples spread over the surface with the radius of each circle increasing at the rate of 3/2 feet per second. That means the RDT is 3/2 feet per second. Find the rate at which the area is changing. So dAdt at what point? When R is 4. So this is the translation of this word problem. And we start with A equals pi r squared, and we want to find dAdt, which is pi because it's a number, and we're going to differentiate just r squared, which is 2r dr dt, or 2 pi r dr dt. So we are ready to plug in r equals 4 feet, dr dt is 3/2 feet per second. So we get 12 pi precisely, units of the area over units of time, or just again, remember 4 is 4 feet and 3/2 is feet per second. So square feet per second, 12 pi square feet per second. Always, always write the exact answer. Then if they ask for an approximation, you use as many as they ask you. In this case, there's 7.6991 square feet per second. A spherical balloon is deflating, losing 8 cubic centimeters of air per minute. At the moment when the radius of the balloon is 20 centimeters, how fast is the radius changing? We are dealing with a spherical shape, so we should know the volume is 4/3 power cube. So we have the formula. Now we go back and reread it. A spherical balloon is deflating, losing 8 cubic centimeters of air per minute. That is dV dt is negative 8 cubic centimeters per minute. dV dt. At the moment when the radius is 20 centimeters, when r is 20, we want to know how fast the radius is changing. That means we want to know dr dt. So we're going to write, here's the formula for the volume. dV dt is negative 8 cubic centimeters per minute. dr dt is of interest to us at the moment that r is equal to 20 centimeters. So having said that, we are going to go with dV dt, and we start with 4/3 pi, and we don't do anything to 4/3 pi because it's a number, everybody. It's a coefficient. So 4/3 pi. Then we're going to differentiate r cubed. And we are going to differentiate it with respect to time. So 3r squared dr dt. And we get 4 pi r squared dr dt. We have a choice. We can solve for dr dt, or we can plug in. If we plug in dV dt is negative 8 and r is 20, replace it. Of course, this is 400 times 4 becomes 1600. So we are dealing with 1600 pi here. So dr dt is negative 8 divided by 1600 pi. 16 and negative 8 cancel each other. This becomes -1, this becomes 2, meaning the numerator is -1, the denominator is 2 with two zeros. That means 200 pi. Units of the radius over units of time. That means centimeters per minute. Again, an exact answer. If they ask for so many decimals, you put it in a calculator. Almost negative 0.001592 centimeters per minute, which means the radius is decreasing at the rate of 1 over 200 pi, the exact answer, centimeters per minute. Notice I didn't put the negative here because decreasing will take care of the sign. If it were positive, you would say increasing if this was positive, and that would take care of that too. So it's all about the sign. We're going to graph f of x equals minus x cubed plus x squared plus x. And of course, I have mentioned that when you want to graph that, you have to use information from pre-calculus and then add calculus. So this is adding calculus. The first thing before even we look at the calculus part, let's find the intercepts. To find the intercepts, number one, this can be factored out. If I take the negative x out, I get x squared minus x minus 1. And the reason I'm taking negative x out, everybody, is because if this could be factored, I want the coefficient for the leading term, namely x squared, to be positive. It can't be factored. So I'm going to set this equal to 0. And setting this equal to 0 gives me x equals 0. And then this 1 equal to 0 requires a quadratic formula. X equals minus b plus minus a squared of b squared minus 4ac over 2a. So it means, okay, this part means x is 0. This part means a is 1, b is -1, c is -1. So you plug in. So minus b, that means minus 1 is 1 plus minus a squared of b squared minus 1 quantity squared minus 4ac. So this is 1, this is positive 4, and we get 1 plus minus squared of 5 over 2. What does it mean? It means x equals 0, the pair is 0, 0. This means 1 plus square root of 5 over 2 and 1 minus square root of 5 over 2, each one, comma 0. Again, we could graph this, okay, without paying attention to calculus. To give you an idea, this is minus x cubed. So all you have to do, plot these 3 points, and this means the second and the fourth quadrant, you have the graph. But we are going to sketch the graph using calculus as well. So we're going to start with f prime of x. So CP is f prime of x, and over here we get a negative 3x squared plus 2x plus 1. And to set this equal to 0 and solve, I'm going to factor the negative sign out. And because 3 is a prime number, you have 1x and 3x. And because this is -1, you have no choice but to go with 1 and -1. Now, where do you put them? You have to work the middle term. If you look at the middle term here, minus 3x, positive x. If you add them up, okay, must become plus 2x. And with this negative, it becomes in an even. So if it's equal to 0, either x is 1 or negative 1/3. Let me erase my work. Either x is 1 or negative 1/3. So we go with the first derivative test. That means we have a number line from negative to positive infinity, everybody. We put the two numbers in order from smallest to larger. The smaller of the two is negative 1/3. The larger is 1. At x equals negative 1/3, f prime is 0. At x equals 1, f prime is 0. Now we are going to go with TP is short for test points. Obviously, in between, the easiest one would be 0. This one would be negative 1. This one would be 2. However, I'm going to just check one of them, and here's the reason. When f prime has only has two solutions, okay, and has exponent 2 and has two solutions, they will alternate. So if you plug in 0 into any of them, in the factor from or this one, it's easier to go here. This one goes to 0. If I plug in 0, I get +1. So I get positive here. And these two alternate. That's the fastest and easiest way. I'm going to throw in the arrows because the arrows will help me see. Arrow down decreasing, arrow up increasing means this is the location of local mean. The local mean occurs at x equals -1/3. Arrow up, arrow down, this is the location of a local max. Local max occurs at x equals 1. What is the pair? You have to put both of them back into the original equation. So actually, 1 is easy to evaluate. If I put the 1 here, everybody, let me just show you how fast you can come up with the answer. If I put the 1 into this, I get negative 1 cubed plus 1 squared plus 1. And I hope you see that we get 1 because this is negative 1, this is positive 1, they cancel each other. So we get 1. We say local max is 1 at 1, 1. But what about local minimum? You have to put the negative 1/3 back into the original function and evaluate it. So let me erase my work. And what it means, I'm going to put negative 1/3 into this or this. Doesn't matter. This is easier. So first and foremost, negative 1/3 to the power of 3 is negative 1/27. This makes it positive. Plus square, when you square a negative number, becomes positive 1/9. And obviously 27 is the common denominator. Therefore, this becomes 3/27 minus, this becomes 9/27. So 1 plus 3, 4 minus 9 is minus 5/27. And we write local minimum equals negative 5/27 at the pair. The function is increasing here from negative 1/3 to 1 and decreasing here. That means from negative infinity to negative 1/3, union 1 to infinity. So as you can see, we have a lot of information here. And now we are almost ready to graph. We are going to use the second derivative test to find the inflection point, the concavity test. And so we are going to rewrite the question with f of x and f prime of x and the intercepts and max and mean and local max and mean. And now we are going to find the inflection point. So f double prime, if this is f prime, f double prime is negative 6x plus 2. So f double prime, negative 6x plus 2. And if you set it equal to 0, I hope you realize x becomes 1/3. So everybody can handle it. This is fairly basic. So you go with the number line from negative to positive infinity, and you put this here. At x equals 1/3, f double prime is 0, and you are going to do the test point, TPs for short. To the left of 1/3, just 0. And to the right, just 1. So if I replace the x with 0, minus 6 times 0, 0 plus, so it becomes plus 2. I just want the sign plus, and it will alternate. Again, why does it alternate? This is degree 1 and has only one solution. That's it. So if it alternates, means it's concave up here from negative infinity to 1/3. It's concave down here from 1/3 to infinity because it's negative. And because of the change, it doesn't matter from positive or negative or vice versa, this is the location of an inflection point. So if 1/3 is the location of an inflection point, what is the point? X comma y, you have to plug it back into the original function. So evaluate the original function when x is 1/3. F of 1/3 is negative 1/3 cubed plus 1/3 squared plus 1/3. So this is 1 over 27. This makes it negative. This is 1 over 9. This is 1 over 3. And again, 27 is a common denominator. So if this is 27, then this is 3. If this is 27, then this is 9. Negative 1 plus 3 plus 9 is plus 11. So 11 over 27. And that is the inflection point having precise coordinations, precise coordinates of 1/3 and 11 over 27. Now we want to graph it. I'm going to write a summary table of all the information we have. This is nothing brand new. We just summarize the numbers here so it becomes easy to just read it from here and put it into the graph. Starting with 0, 0. 1 minus square root of 5 is negative 0.620. This is for the sake of graph, everybody. Okay. So this is negative 1, so 0.6, negative 0.6 is somewhere close to that. And this is 1.621 is here, so 1.6 roughly it's there. And by the way, the graph will cross all of those because none of them has a multiplicity even. Then maximum occurs at 1, 1 here, and we go with a double arrow because maximum in the graph of a polynomial function means it can't cross it. IP, we're going to go with the decimal representation, let's say 0.3, 0.4, so here and here, somewhere there. So that's the inflection point. The minimum occurs at this point precisely, again, negative 0.3, let's say negative 0.2 roughly. So negative 0.3 and negative 0.2, somewhere there. And we know it's a minimum, so again, double arrow. And this is the leading term, which means the second and the fourth quadrant. So it goes like that. And notice, I'm going to erase my work. Notice the function is decreasing here, increasing, decreasing, and it's concave up, concave down. So the IP, everything is precisely defined. A 20-foot ladder leans against a building. The base of the ladder slips away at the rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building. You have to draw the setting. So here's the wall or the building. Here's the ladder. It slips away this way. And that's at a rate or speed of 2 feet per minute. So that's the speed. Dx dt is 2 feet per minute. It comes down this way and it creates this shape, which is a right triangle. As it comes down, it creates the speed dy dt. And that's what we are looking for. In the meantime, the ladder has the fixed length of 20 feet. So this tells all the story. So this is the translation. Now we're going to write dx dt is 2 feet per minute. And we know, according to Pythagorean theorem, a squared plus b squared is c squared. So for us, x squared plus y squared is 20 squared. And we want to find dy dt when x is 12 feet. So this is the precise translation here. And we have defined our variable with the help of a drawing. Now we're going to differentiate this. With respect to t, we get 2x dx dt. Over here, we get 2y dy dt. 20 squared or 400 is a number, we get 0. We have everything we can plug in, and we notice y is missing. So when x is 12, plug it in. So x is 12, plug it in. You get 12 squared plus y squared is 20 squared. 12 squared is 144. 20 squared is 400. You move this. You subtract from 144. You get 256. And y becomes the square root of that, which is 16 feet. And now we can plug in. 2 times 12 times 2 is 48. 2 times 16 is 32. We're going to move the 48. We're going to divide both sides by 32. Both numbers are divisible by 16. We get negative 3 halves units feet per minute. X is increasing, dx dt is positive, y is decreasing, dy dt must be negative, and it is.